The first part of the notes for today is a warm-up, a set of warm-up problems. And our task is to write each equation in slope-intercept form. Now notice I have the solve for y written off to the side, and that's really all we need to do here. Because slope-intercept form is y equals mx plus b. And so for all of these problems, what we are trying to do is get y by itself. We're moving terms around to accommodate the fact that we need to get y by itself on the left-hand side of the equation. So let's take a look at number 1. I see y minus x equals 1. The first thing we need to do is to get rid of this negative x, so we add it to the other side. We add x to the other side. The reason we do that is so we can cross it off right there. And now 1 plus x on the right hand side. 1 is a constant, x is a variable. We can't combine those items because they are not like terms. So my result is y equals x plus 1, and I'm done with that problem. Number 2, a little more to it. We have 2 steps instead of just the 1. I have to move 2x to the right hand side by subtracting it, because 2x minus 2x is 0. We bring down our 3y, and I'm left with negative 2x plus 6. I'm almost done. I'm still trying to solve for y, and I have this 3 in the way. This 3 is being multiplied by y, so I need to divide. To undo multiplication, we divide. Because 3 over 3 is equal to 1, now I am all alone on the left-hand side with y, which is what the goal is. Now, negative 2 divided by 3 is a fraction. Keep it as a fraction. And then 6 divided by 3 is positive 2. And I am done there. Number 3, the y, notice it is on the right-hand side of the equation. That's okay. We could still proceed to get y by itself, regardless of what side it's on. 5y equals 0 minus 5x is negative 5x. And I'm solving for y still, so I will divide both sides. And I get negative 5 divided by 5, which is negative 1x. So there's your warm-up problems. Moving on to the actual lesson for today. It starts with a few definitions. And what I have highlighted for you is what goes in the blanks on your notes, so I'd like for you to go ahead and write those in. Essentially, graphing a system of equations is this. A system of linear equations, what are they? It is a set of 2 or more linear equations containing 2 or more variables. A solution of a system with 2 variables is an ordered pair. I underline the words ordered pair because it is very important to note. Okay? A solution is an ordered pair that satisfies each equation in the system. And it says if an ordered pair is a solution, it'll make both equations true. And that'll make more sense on the next page. Alright, so let's jump into it. Number 1, I'm given an ordered pair, 1, 3. And I'm also given 2 lines. The line on the top and the line on the bottom. And basically what I'm after, well, let's say we have a line on the top and a line on the bottom. What we're trying to figure out is 1, 3 where these 2 lines intersect. Well, algebraically, we could figure that out by taking x equals 1 and y equals 3 and substituting x and y into both equations. If it comes out 5 on the top equation and 1 on the bottom equation, then yes, 1, 3 is where these 2 lines cross. So let's take a look at the top equation. 2x plus y equals 5. I will substitute 1 for x and 5 for y. I'm sorry, 3 for y. My mistake. Let's fix that. And 2 times 1 is 2, plus 3 more. Hey, that's good news. We have a solution there. But that's not good enough. We have to check the next one. The next one is negative 2x plus y equals 1. We'll still plug in 1 for x and 3 for y. And we get negative 2 plus 3 equals 1, which is true. So we would write the word yes for number 1 because both equations are true. Number 2, same drill, x comma y. The top equation, the bottom equation, let's do it. X equals 2 on the top, minus 2 times y, which is negative 1. We're trying to figure out if it's equal to positive 4. Well, negative 2 times negative 1 is positive 2. And hey, guess what? 2 plus 2 is indeed equal to 4. The next equation, 3x plus y equals, I'm going to run out of room here, 6. So on the left-hand side, I have 3 times 2, which is 6, minus 1. 5, ladies and gentlemen, does not equal 6. So we circle that and we say no. We say no. 2 comma negative 1 is not the location of where these two lines intersect. Now checking out these examples 3 and 4, I'd like for you to go ahead and pause the video and work these two problems out on your own. I'm going to put the solutions up on the screen, and so after you hit play, you'll see the solutions, and hopefully they line up with your work. So go ahead and pause the video now and attempt number 3 and number 4. Okay, at this time, hopefully you have attempted 3 and 4, and it turns out that neither one of these are solutions. Negative 2 comma 2 for number 3 is not the location where these two lines intersect. And on number 4, 5 comma 2 is not where these two lines intersect either. So now what we're going to do is we're going to take these lines and actually graph them to figure out the exact location where the two cross and intersect. So I believe we're now flipping your notes to the back page, and we have a few problems that we need to attempt, which involves graphing. Now graphing is it involves around y equals mx plus b. So in your notes it says graph both equations either by slope-intercept form, which is y equals mx plus b, or the x and y intercepts. I've also written here the cover-up method. That's another tool that you could use to find the y and x intercepts. Your solution will be where the two lines intersect. I kind of already touched on that. So let's get to work and try some problems. Now, the first one starts with the first equation, x plus y equals 0. If I take x plus y equals 0 and I try to put it into slope-intercept form, what I will have to do is subtract x both sides, and I will come up with an equation that reads like this: y equals negative x plus 0. Now before I graph anything, let's review y equals mx plus b. The other day we went through this. M is my slope, b is my y-intercept. If my slope is negative 1, starting at 0, that's where I will start because that's my y-intercept. Now my slope is negative 1, so I will go down 1, right 1. down 1, right 1, and so on. I will continue this pattern a lot of times because we're trying to figure out where these two lines are going to intersect. It's not a bad idea to make a bunch of ordered pairs. It's just helpful. Alright. Not the greatest line in the world, but hey, it'll work. The second line, this is line number 1. This is line number 2. So line number 1 is there. Line number 2 is already in slope-intercept form. Now what I want you to do before you do anything else is I want you to change something for me. I just realized that the slope of line number 2 should be negative 1/2 and not positive 1/2. So that changes things a little bit. Our slope is negative 1/2 and our y-intercept is 1. So we'll start here on the y-axis. But now we're going to implement a negative 1/2 slope. We're going to go down 1, right 2. Down 1, right 2. Well, if we keep going in this direction, we will never hit the black line. So what we need to do from my y-intercept, why don't we try going up 1, left 2. And bingo, right there. At that moment, that is where the two lines will cross, and we can go ahead and, my lines are terrible today. We can go ahead and cross them off. And let's figure out what that ordered pair is. That ordered pair goes 2 times to the left from the origin. 2 times to the left. So 1, 2, and then up 2. So that ordered pair is negative 2, positive 2. This is your solution, ladies and gentlemen. So that's the whole idea here. We're going to graph 2 lines and figure out where they cross. Now the next one. The next one has lines y equals negative 2x plus 1. That's line number 1. And then line number 2 is y equals x plus 5. Let's take a look at line number 1. Y equals negative 2x minus 1. Our rise over run is negative 2 over 1. And our y-intercept is negative 1. So I will start by plotting the ordered pair 0, negative 1. And now I will implement a negative 2 slope, down 2, right 1. Down 2, right 1, and so on. You could do this for the whole grid if you would like. Because the nice part about that is on line number 2, one of the ordered pairs should collide with one of these. So here you are. My red line, there she is. Number 2. Y equals x plus 5. My rise over run is 1. And my starting point is up at 5. So let's start there. 5, here we are. Okay, now my slope is up 1 over 1. Up 1 over 1. And we will continue the process. But wait a minute, I'm not getting closer going that way. Let's go the other direction. Down 1 left. Down 1 left. Boom, there it is. There it is. My ordered pair is negative 2 on the x-axis from the origin, 2 to the left, and up 3 units. So again, plotting 2 lines using slope and y-intercepts, rise over run, etc., and then your final answer needs to be an ordered pair. Where exactly do these 2 lines intersect? Now I'm going to go ahead and put the solutions for the next 2 problems on this video, so I would advise you to pause the video at this moment, try the next 2 problems, and then when you're ready to check your answers, go ahead and hit play again. Good luck. Alright, here's the solution for number 3. The answer is the ordered pair 3, negative 2. So go ahead and fix any mistakes that you had made, or continue on to the next problem. Okay, here's the solution for number 4. The answer is 3 comma 1, and number 4 here was kind of tough because you had two equations written in standard form. So if you look at the red line, you had to move pieces to the right hand side and also divide by 3. Okay, that gave you a slope of negative 1/3. It also gave you a y-intercept of 2. Line number 2 now. It's a bit complicated because what does a y-intercept of negative 7/5 look like? But you won't run into that 95% of the time. Every once in a while, we might throw a curveball at you. Negative 7.5 has a decimal approximation of negative 1.4. So if you look here, I had to estimate where that goes. And from there, I had to implement a positive 4/5 slope up 4 to the right 5. And luckily, with the two lines, once you just graph them, luckily they intersect at 3 comma 1. Now at this point, you should be able to attempt the homework assignment for this evening. Good luck. Come back tomorrow with questions, and we will go over it then.